All right, so these are the last two questions from chapter 3. So this first part, we've got all our conversions, so I'll refer to them when we need them. Um, all right, so on this first one, it looks like we got the radius of a spool of thread. The thread is being pulled off at a rate of, underline this, a rate of 59.4 centimeters per second. Find the radius of the spool if it makes 152 revolutions per minute. So if you haven't worked this out yet, I suggest you pause the video and try to play around with it, okay? But I'm going to go ahead and just work through the problem. So right here, they're giving you a distance right here per second, okay? And so that's actually equivalent to like arc length, okay? Because you got your spool of thread that's a cylinder and it keeps getting pulled off of that. And so that's equivalent to arc length. So the formula for arc length, we use S is equal to the radius times theta. Okay, so in this instance, you have this right here in terms of centimeters per second. So that's what we have right here, 59.4 centimeters per second. So you know this right here. If you could just figure out theta right there, then you could go ahead and solve for the radius. Well, you can solve for theta because over here, you know that it's going to go 152 revolutions per minute, okay? Well, if you want to break that down into seconds, because you're going to have we're going to have to use common units. So to get this into seconds, there's 60 seconds per minute. So I divide by 60. So this is be 152 divided by 60, which we can simplify if we want, but doesn't really make that big of a difference because we're going to use the calculator in a minute. So that converts this to revolutions per second. Okay, so that's revolutions though. That is not theta right there. That's not what I want to plug in there. So if we go back up here in my conversions, you can see that one revolution is equivalent to 2 radians, okay? And so just so we can have a better feel for this, I'll go ahead and stick this in the calculator so you can see this. Gives a better idea. So let's turn this on. There we go. All right, so 152 divided by 60. Okay, so, oops. Okay, yeah, that's right, that's right. Okay, so basically it's making a little more than 2.5 revolutions per minute, right? So I'm sorry, per second. So every second this thing is spinning, it's spinning off the thread, okay? So every second it goes around 2.5 times about. So that's kind of what that is. All right. So, but that's not theta. So to get it in terms of theta, we're going to have to go ahead and do another conversion. And in this conversion, we're going to multiply by 2 pi because every revolution is equivalent to 2 pi radians. So we multiply this by 2 pi. And once again, I mean, I could simplify it, but I'm going to plug it in the calculator in just a second anyways. So anyways, this would be 304 pi divided by 60 when I multiply the 2 pi by the 152 on top. So now instead of being revolutions, that's going to be radians per second. So now I know how many radians this thing is, the angle is going every second. And once again, if you wanted to, you could put it in the calculator so you have a better idea of what that number looks like. So anyways, all right. So now it's time to go back to our where we started. So like I said, in this problem, we already know what S is. S is my arc length, and they gave that to us. They said it goes 59.4 centimeters per second. So radius, we don't know the radius. We want to figure that out. And then this would be our theta. It's going to be 304 pi all over 6. Like I said, I mean, you can reduce this fraction if you want, but at this point, I'm about to put it in the calculator. So what I'm going to do is basically we're going to multiply by the reciprocal on both sides, or you can divide if you want. It doesn't really matter. And so then over here, I'd multiply by, let me see, get that out of my way. Let's see. There we go. Okay, so here, there we go. So here we'll go ahead and multiply this by the same thing, 6 over 304 pi. Okay, and so just make sure that when you put this in the calculator, you put it in exactly how it looks right here, and you'll see my calculator pop up in a second. All right, so here we go. So I'm going to go ahead and put parentheses 6 divided by 304 pi. Okay, and then we'll go ahead and close the parentheses. And then let's see, times 59.4. All right. So we're going to get a radius of 3 point, we can round that to just 3.68, that's fine. So our radius is 3.68 centimeters. So that would be the radius. And that seems fairly reasonable. And all right. Okay. So that's that one. We got one more to go for this notes. So I'll go ahead and start scrolling down. Okay, so another bicycle problem. This problem is not super difficult. There's just a lot of conversions that are going to take place in this problem. So once again, if this is the first time you're doing this, I would pause the video, at least try to think about this for a minute or two and see if you can kind of figure your way through this, because you're going to have to do it on the test anyways. So might as well get some practice now. But I'll go ahead and start. So here we go. So we do have our radius right here, 13 inches on our bike. So we want to figure out the speed of the bike. So they tell us right here, we're looking for the speed of the bike. So the tires of the bike radius of 13 inches, and they're turning at a rate of 215 revolutions per minute. So right here it says, how fast is the bike traveling in miles per hour? So I think speed is going to be your distance divided by time, right? Your speed. It's how far you've gone over that amount of time. So we're doing miles per hour. So basically we need to figure out how far this bike goes in an hour, and then that's it basically. Because if you're going to divide it by an hour, that's not really going to, it's like dividing by 1, so it's not going to do much. All right, let me clean this up a little bit. Let me a couple marks here. Okay. So, well, what do we know so far? Well, if I want to figure out distance, that's basically the same thing as arc length, right? When we're talking about a tire, the distance of it going around here, that's arc length. And so it's going around many, many times, but that's what you're finding. That's what S is, okay? So we're dealing very similar to the problem up above. So that's going to be theta times the radius over time, or whatever, vice versa. And so we already know, look, we already know if we can get our conversions right, we already know that time is going to be 1. So really, it's just going to be theta times radius. And we already know what radius is. So really, the only thing that we're missing here is theta. And we need it in radians per hour. We need it in radians per hour. So this problem, the previous problem, we were kind of scaling down. We went from, I think it was minutes to seconds and so on. This problem's actually, we're going to be scaling up, it looks like, because it gives us revolutions per minute, right? So we go 215 revolutions per minute, but they're asking for our units to be in hours. So we would go ahead, this time we're actually going to increase by 60-fold. So we're going to multiply by 60. So let's see. 215, oops, not divide, let's see, times 60. And so that's going to give us 12,900. Okay. And so that's going to be revolutions per hour. Okay. But that's not what theta is. If you recall, we have to go ahead and we're going to have to multiply that by 2 pi. So that's what we'll do here. We'll multiply this by 2 pi. And I would just leave it in terms of pi right now. So that would be 25,800 pi. And so then that's radians per hour. Okay. So we've already done quite a few conversions, but actually this next part, we're actually going to just continue to do a lot more. So the speed of the bike right here is theta times the radius. So we're going to take 25,800, 25,800 pi, and we're going to multiply that by the radius, which was 13. So the thing is here, we're about to get the speed of the bike in inches per hour. So we're going to have to do a lot more conversions in a second. So let's see. I'm going to go ahead and take, let's see. So if I go ahead and get, there's 25,800. So I'm going to go ahead and multiply that by 13. So times 13. So that gives us, and if I want to, I can go ahead and do pi now, or I can leave it as pi. I guess I'll go ahead and apply pi to it. So let's see, times the pi part. Okay, so this is going to be a big number. So let me see if I can make my life a little bit easier here. So let's see. Okay. Oh, I don't know if it's going to allow me to paste. Let's see. I guess I'm going to a lot of trouble to save myself time when it's actually not going to save me time. Okay. All right, so let's see, what is that number? So let's see, 1,053,690. So 1 million, come on, pen tool. 1 million, what did I say? 1,053,000. What the? Uh-oh, I really screwed things up. All right, so let's see, 690. So you're gonna have to, okay, looks okay. Let me pause this and try to figure this out. Okay, I think I fixed what was wrong, but okay. So I went ahead and multiplied this together right here, 25,800 pi times 13. And so it gave me 1,053,690.2 inches per hour. Okay, so that asked for miles per hour. So we're going to have to scale inches all the way up to miles. And I mean, you could do it all at once, but I'm thinking most people, it'll be easier if we do it in 2 steps instead of 1. All right, so if I want to convert from inches to feet, well, every 12 inches gives me a foot. So I'm going to divide this by 12, and so every group of 12 will give me will convert that to a foot for me. So that's what we'll do here. So I'm going to take that answer, I'm going to divide it by 12, and so we're going to get 87,000. Let's see, 87,807.5. And so now that's going to be feet per hour. But once again, I need to put it into miles. And so then if you look up above, I do have this conversion for you right there. So every 5,280 feet, that'll give you a mile. So we're going to divide that by 5,280. So that will convert it to miles for us. So divided by 5,280 right here. So we're going to get 16.6. That sounds good. So 16.6 miles per hour. And the important thing here is that's reasonable, okay? So if you would have gotten your answer in millions, you should be like, oh, wait a second, that's inches. And so you got to catch yourself. So don't do anything crazy. So just always check for reasonableness. All right, so that is the end of chapter 3. I'm going to make a short video for the beginning of chapter 4 for those that were absent.